list, we have Olivier Jeunen, who is going to present a paper with a compelling title, I would say, Pessimistic Reward Models for Off-Policy Learning in Recommendation. Yeah.
Right, thanks, and hi everyone. Yeah, let's start. We frame the basic task of recommendation in a bandit learning framework here. So here you have a certain agent, which can take certain actions, which is basically showing a certain recommendation to a user. And then the agent can observe a reward or no reward from that action, which is a click or no click, for example. And then the goal is for the agents to actually learn which, the goal for the agent is to learn which basically certain actions it should be taking in order to maximize the reward that it's going to get. And then we deal with the sort of off policy setting here. So here you have a certain fixed data set with certain things that were being shown to users, and then whether the user clicks on it or not. And from this fixed data set, we need to learn a single policy to basically choose which recommendation is going to be the better one. But this is not an easy problem because we might not know very much about the main system that was in place at the main system that was in place at the time of data collection, and then you have a lot of selection bias, which is going to make things harder. But one thing that people do really often is something called the direct method, where you basically try to model how likely a certain action is to lead to a reward given a certain context. So then the first step is to learn a simple sort of classifier for the probability of a click given a certain context action pair. And then the second step is when a user comes to the system, we simply sort of take the action that has the highest probability of leading to a reward. And that's the action with a star. And so this all seems rather simple and rather straightforward, but actually you run into a problem when you do this. And that's called the optimizer's curse. And so this basically states that even when you have a sort of unbiased estimator for the probability of reward over all of the actions, as is shown in the first equation, for the maximal action, you actually are very likely to sort of have an overestimation. And so this means that you should expect to be disappointed when you're going to act according to these best estimates from your model. And so maybe even slightly more intuitively, when you have a certain unbiased estimator, some of your actions are going to be slightly underestimated, some will be slightly overestimated, but because you are taking a sort of argmax over that, you're very likely to get those that are slightly overestimated. And the solution is to be explicitly sort of pessimistic with your reward estimates. But how would you do that? Well, suppose I have a certain action, and I basically took it twice, and I got one click and one non-click. When you then plot your sort of likelihood function, we can see that our maximum likelihood estimate for the probability of a click on that action is at 0.5. But that's a very, very high number, and it's very likely that this is actually not the true estimate. So what people then sort of do is use a prior and look at a map estimate, and so then we might assume that our new estimate is at 0.35, because now we know that it's basically a way better to also basically take this prior information into account when you don't have a lot of data. But so we propose to go one step further even, and to really be sort of explicitly pessimistic. So we basically choose to define a certain shaded region alpha, which is now going to show a lower quantile of the posterior. And so what this basically does is, when you have a very narrow posterior, the same value of alpha is then basically going to give you a very small penalty. But for very wide posteriors, the same value of alpha is going to give you a very large penalty. And so, and so basically this is then doing some sort of, basically this is doing some sort of sample variance penalization that you then get, and you get a nice bias variance trade-off. And so this is nice for a single action, but it's actually way more interesting when you have multiple actions. So suppose we have this first action, which was basically shown twice and got one click. Suppose we have a second action that was shown slightly more often but received slightly fewer clicks. And then a third action, which was really taken really, really often, but got even fewer clicks. So when you would basically take your actions based according to the maximum likelihood estimate, you would take the first action. When you would take them according to the map estimate, you would take the second action. But we propose to actually take the third action because that has the maximal sort of lower confidence bound on the sort of confidence interval there. And then maybe as a small sort of side note, I'm assuming that there are many people in this room who are now thinking of basically things like policy learning. And there, the main goal is not really to learn a certain probability of the reward for a certain context action pair, but the goal is really to learn a certain policy that is going to be a probability probability distribution over actions that is then basically going to try to maximize this sort of counterfactual reward. And so here, the main problem that you actually get is that these weights that are shown there on the right are actually going to become way, way too high, and there's huge variance on them. But there's many, many ways to actually deal with this, and they all boil down to being explicitly sort of pessimistic. And that is maybe the simplest to see when you think of clipping, because that is really just saying, well, when this ratio is becoming too high, I'm no longer going to, when this ratio is becoming too high, I'm no longer going to fully trust my data, and I'm choosing to have a new estimator that is no longer sort of unbiased, but we have lower variance, and that's going to work better. Okay, so then we can go back to the value-based models. So what you would normally do is just take the action that has the highest probability of a reward, and then you basically try to answer, well, what is the best outcome? But we propose to actually use some sort of pessimistic reward model where you're no longer looking at what you think is the best outcome, but what's the best worst case outcome. Okay, so does this actually work in practice? Because it's a very sort of general method, we now need to choose a certain model class to focus on. And we choose basically to flip the sign in LinUCB, which is very well known in these like sort of on-policy applications, where it's well known that you should actually be sort of optimistic instead. And the reason that we take this is because then you have a sort of closed form model for both the mean and the variance of the posterior, which is always very nice to have. It's not easy to do some sort of purely offline evaluation with these things. So that's why we also choose to do some simulated experiments with RecOGym. And then we vary the rate of exploration in the logging policy, because that's going to give us more or less sort of bias. And then we vary the size of the action space and the size of the training sample. And so the main sort of question that we have is, well, when can it actually improve performance? So what you see here are some results from simulated A/B tests. So the leftmost column shows when there is strong selection bias, and going to the rightmost where there is no selection bias. The rows are differently sized action spaces. You can see that we increase the size of the training sample over the x-axis, and then we show the reward that a model got over the y-axis. And so we compare the logging policy, a certain skyline policy, and then those that learned from the maximum likelihood estimates, the map estimate, or the lower confidence bound-based estimates. And so the first thing that you notice is that, well, there's basically no difference in the sort of upper right corner there. And that's also true because there's no use in being pessimistic when you have no selection bias. But we can see for the more sort of lower left region of the plot that there's actually value in being pessimistic, and it's really giving you a nice boost sort of over these map estimates still. And this sort of basically keeps going on. If you increase it to 50, 100, and then 250 actions, you can see that it's really sort of nice trends of having value in being pessimistic. Okay, so it's most effective when you have small training samples, when you have a small amount of randomization, so a high amount of selection bias, and a larger action space. And so this really makes sense to me as well, because this means that a certain region of your context action space is not going to be well explored, and then you're very likely to have a single sort of item there that is going to be slightly overestimated. And when you then just basically take the simple argmax, then this is the item that you're going to be showing to basically everyone. Okay, so as a takeaway message, when you're going to learn a model for the probability of click on recommendations, there's a good chance that some items are going to be slightly overestimated. And then if you take an argmax, you're just very likely to actually show these ones. But so this really can be fixed by being explicitly pessimistic with your predictions. As future work, I believe there are many things we can do. First of all, it certainly would be nice to have some sort of further validation that is not purely focused on sort of offline data. Then we would also like to explore the value of this method in terms of offline evaluation, because then it also might have some gains there. And then certainly it's also important to look at the sort of impact of these methods when you have multiple iterations of logging and learning. Because now we have a single iteration where it's a fixed data set, you learn a model, and that is the model that you actually go to deploy. But that's not too sort of realistic. And being pessimistic will make sure that you focus on purely basically some sort of exploitation, and that might have some sort of bad impacts on the informational value of the data that you collect, and also feedback loops and filter bubbles and all of that, which is really not good, of course. So these are things that we would like to explore further in the future. Then I would like to thank you all for your attention. I have some QR codes to the slides and the code there, and I'll be happy to take any questions.
Thanks a lot, Olivier.
Thanks.
So we have time for a couple of quick questions. So one is, so I'm going to try to make some links to related concepts. So just feel free to tell me they don't make any sense,
Okay.
in case that's the case. So you have the concept of optimism versus pessimism, like in multi-armed bandits and so on. So for instance, you can, when you configure the parameters of a multi-armed bandit, you can do like a pessimistic configuration, or when you choose priors, you can choose like a low reward prior as a pessimistic way to make your approach to give a pessimistic ingredient. That is also related to whether you want to do more exploration or less.
Yeah, certainly.
How does this relate to that? I mean,
so, I mean, these things are certainly sort of very closely related, but it's not always that easy to find a good prior, right? Because they're sometimes sort of very hard to tune. It's not always clear what it should be. Sometimes it's going to be fully uniform over the entire set of items, which might also not be something that you want. So that certainly has value, and that's also basically something that we see is that doing a map estimate is already way, way better than doing a simple sort of maximum likelihood estimate. But even there, having some sort of added like sort of sample variance penalization on top still brings some additional value. And that really basically boils down to doing no sort of exploration whatsoever anymore. So it's fine in this setting, but it certainly might have some bad effects if you start doing this in production, which is also important to mention, I think.
Thank you. We have one question from the audience here.
Yeah, that was actually sort of, is it good? Yeah. Sort of related, because being pessimistic, I guess, is very good if you have a very large action space with lots of items where you basically cannot explore all the items, but you might end up in an issue like if you are pessimistic, you will sort of go for the safe bets that have 5% of click probability, or you're sure it has 5% click probability, but if you put it in production, you will never actually discover the new items that might come out.
Yeah, exactly.
And
so,
also, okay.
Sorry.
Maybe that's a question, like you mentioned UCB upper confidence bound, like how you compared your method with that and seen how that could pan out in a recommender setting?
Right, yeah. So I feel like that would certainly work better when you have these sort of multiple iterations of logging and learning. But there it's really, I mean, there is like some sort of difference and you see some sort of trade-off between these sort of purely on-policy applications and sort of basically purely off-policy. And I would say it's all about sort of the size of the window before you basically do an update. So when that window is very, very small, it helps to be sort of slightly optimistic because you'll never be it for too long because you'll learn it if you're being sort of way too optimistic. But if that window is very, very large, then you're basically in some sort of off-policy application. And then you might be showing something the entire time that's really not that good, and you won't be able to learn that it's not that good because it's a very long time before you do a model update. So I feel like there it's, going to be like some sort of trade-off. If you can do fast model updates, it's probably better to be slightly optimistic. But if you can't do that, maybe it's better to be less optimistic or even slightly pessimistic, because it might take a very long time before you actually learn that you're showing something that isn't that good. Yeah. Thanks.
Okay, thanks. Thanks, Olivier.
Thank you.
So this concludes this second session, and let's go for the coffee break before the third and last session.